Welcome back. We're still in the command line book. We're doing chapters 9 through 12 this video. Okay, so let's get started. So the first chapter we're going to be talking about is about permissions. And you got to think about this from a slightly different perspective. In the personal computer days, a personal computer meant it was your computer and nobody else was on it, and therefore you didn't have to worry about permissions, because why on earth would you want to not have read permission for yourself? So the only time that permissions really became a real big thing is when you had multi-user computer systems, which of course, all Linuxes are. You have multiple people on simultaneously, and therefore I need to protect some files and things like that. So it is the byproduct of the multi-user environment is where permissions really came into. So let me just ask you, just out of curiosity, an average Windows 10 user, a Windows 10 professional install, how many simultaneous users does it support? 2. On Windows Server, how many does it support? Well, as much as your bank account will allow, but hundreds, maybe potentially even thousands. But right out of the box, Ubuntu and Linux and UNIX, they always had this. It was built with that on purpose from the beginning. So, again, talking back on Windows has a remote desktop protocol. And if you have the professional version, then you can do a remote desktop into another machine, so I can remotely connect to another machine. That works pretty cool. And again, that was kind of bolted on. But in our world, that's always been there. It's always been that you would have a remote terminal. Remember, we called this thing the terminal emulator. A remote terminal that connects to some central machine someplace. So all that's been baked in from the very beginning. So on page 90, they start talking about it again. So one of the problems is the terminology that you use is a little confusing, because the abbreviations change over time. I know it's a little weird, just bear with me. And so the permissions are in 3 sets. They have the permissions for you, which they call the owner or the user, depending on when they talk about it, either the owner or the user. And then they have one called group. So I can be a member of multiple groups. And so let's say I'm a member of the sales group, and that group has been provided, write permission on this folder. Well, then I have write permission on the folder because by virtue of the fact that I'm a member of that group. And then the other one is either everybody or others, depending on what abbreviation they use. So it's you, the group, and then everyone else. So that's the 3 categories of it. So one of the things you can do is you can type, remember the file command? So if I say file, and then I say etc. password, it's going to tell me that, it's a text file. But if I said file, and I'm going to type in one that I know that you don't have permissions on, called shadow, and it comes up and says, it's a regular file, but I don't have any read permission, so I really can't tell you anything about it. So the file command, in a very crude way, can tell you whether or not you have permission. So before we get much further, remember I talked about groups, right? So if I just type ID, that's going to tell me about me, what my numeric user ID is, and then all of the list of groups that I'm a member of. And so my ID is 1000, and my group is 1000, and then I'm a member of my let me start over. My user is 1000, my primary group is 1000, and then I have a bunch of secondary group ones. I'm a member of Emmett Gray again, admin, CD-ROM, sudo, dip, whatever the heck dip is, plug dev, and LXD. So those are the list of groups that I'm in. So let's go back to, I'm going to type less and then go to etc. password one more time. Okay, so the format of this, if you recall, hey, remember how you can find the format of this? You do -5 and then password? Okay, cool. This is a colon separated file. But let's go down towards the bottom and look at this. And it shows Emmett Gray, colon, X, colon, we'll forget about that. And then it says 1000, 1000. The first 1000 is my user ID, the one we found up front. And the second one is my primary group ID. And that's it. Kind of cool, huh? So, where on earth, in the old days, just a matter of historical significance, in the old days, the actual hashed password was in this file. So that X used to contain, XY447 egg, some sort of cryptographic hash for the actual password. The problem is everyone needs permission on this file. And so they wanted to fix it so that if you want to be more secure, I don't want to provide everyone a copy of the cryptographic hash. That way you could take it home and beat on it for days trying to crack it. And so they separated it out. So now we have the etc. password and the etc. Shadow. So I'm going to do a sudo just to show you the shadow thing. So I'm going to do a sudo less etc. shadow. CIS4335 2020. And then there's my cryptographic. So Emmett Gray, and then this god-awful long gobbledygook full of stuff is my cryptographic hashed password. It's not my password, obviously. It's a cached version of the result after the encryption has taken place. Okay, kind of makes sense? All right. So, just for a minute. So, the owner of something can do practically anything. So, what if I made a mistake and took away read permission of my own file? Would I be able to read it? Well, no. But I'd be able to run the command that changes the permission back to give me read permission. Yeah, I could do that because I'm the owner. Now, root has special powers. Essentially what root does, root essentially just bypasses the security check completely. It's instead of saying, hang on a second, let me go see if he has write permission. When you're running root, it goes, screw it, just give it to him. So it doesn't matter what the permissions are when you are root. Even if you don't have read permission on a file as root, like no one has read permission on the entire system, no one. When you're root, you can still read it with no trouble at all. Okay. So remember how when we did ls minus al, and we showed this gargantuan thing. Let's talk about the first column. So the first column is set up in groups of 3. Well, okay, the very, very first column is a D. D stands for directory, or a dash, meaning it's an ordinary file. So D's and R and dashes. And then we have a set of repeating sets of 3 things, an R, a W, and an X. We don't have that many X's here, but nevertheless, an R, a W, or an X. So let me just show you what all that stuff looks like. So here's the file types. A regular file, that first column is going to be a dash, a directory, a symbolic link, if we had any of those, a character file. Now, if we go look in dev, we're going to find some C's and some B's, but that's the only place you're going to find C's and B's. A character device and a block device. Let's don't get into the details, but basically these are devices like the keyboard. The keyboard most likely would be a character device because it's designed to take one character at a time. Right? Makes sense? But a CD-ROM, for example, is going to be a block device because it's designed to handle, huge chunks. You can't say, go give me 1 byte off of that file. It just brings the whole file down. Cool? All right. So that's what that means. And then here are the 3 sets. The owner one, or user, depending on what abbreviation you're using, the group, and then the rest of the world. Okay? So read, write, and execute, and then read, write, and execute again, and read, write, and execute again. Let's go back to that guy to see our example. So let's just pick test 1. So test 1 has read and write for me as the owner, read and write for the group called Emmett Gray, and read only, just read, for everybody else. Kind of makes sense? So that's how you read those things. Okay. So there's some examples on table 9.3 that you might want to just kind of look at, because to tell you the truth, it's not complicated at all. It's just that you should look at those things, okay? So the first one gives me read and write execute only for me. And the next one only provides me for read and write. And the next one provides me for, just go down this little table and kind of make sure you understand it. Because this is a little strange, but not all that strange. One of the things you might think about is execute permission. So execute is really for commands, right? Or is it possible for me to read a command without the ability to execute it? Yeah. Yes, it is. So if I have we haven't really talked about shell scripts any, but when we get to shell scripts, I want to be able to, read and write and execute a shell script. Okay. So those are kinds of things that we expect to be doing. So do kind of go through that list and kind of practice on your own. So how do you change the file permission? Well, in the Unix world, they call this the mode. I don't know why they called it mode. It's just kind of weird. So the change mode command, chmod. Okay, kind of weird. So only the user or the root can change the permissions on a file. Make sense? The group people can't do that, and certainly not the other people. So the owner or our root can do that. So this thing is kind of weird. Now, I don't really want to get into too much detail about octal numbers, but this is one of those situations where you might have to kind of pay attention. So R, W, and X is 0, 1, and 2. Okay? Just from an octal. Let me go ahead and pop this thing up. Okay. So if I wanted just write, I would use a 2. If I wanted to write and execute, it's just one of those weird things. Okay? I'm not asking you to memorize the octal notation. Although 777 is a very, very common one, and that one you might want to, have to memorize it. Just kind of remember that 777 is all the way across the board. So I'm going to do that. So I'm going to go back to my guy here. And let's do test 1. I'm going to say change mode. So I'm going to say 777 test 1. All right. Now what that's going to do, that's going to turn on the read, write, and execute RWX for all 3 columns. The first one, the second one, the third one. Cool? All right. Let me go do that one more time. And let's do that again. Except this time I'm going to say chmod 770. Okay, that's going to get read and write for me, read and write, execute for me, read and write, execute for the group, and nothing at all for everyone else. That kind of makes sense? Okay. And ta-da! That's how that works. Now, again, I'm not gonna force you to memorize octal numbers and how to make this thing work. It's a little pain. But because it's kind of a pain, they provide you an alternate technique. The alternate technique is using symbols rather than octal numbers, which is mo better, right? So table 9.5 gives the symbolic notation version of this. But this is where it gets funky, okay? Look at this very carefully in the book. It says that U, okay, no, U is going to be user. Remember we talked about how it's, the owner and the user are kind of the same thing? G for group, but O is for others. So you see how we shouldn't be calling that one owner, because O means other now, not owner. I mean, I wish they were consistent. This is confusing to a lot of folks, because if you say owner, 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 and then you have the O options, you think, oh, that means owner. Well, no, it doesn't. I know, what a pain. Hey, we're coming up on the 15-minute mark. We'll continue this in just a few.